Okay, so this is interpreting motion graphs. You have to forgive the roaring in the background. That's my son in bed, roaring like a dinosaur on the baby monitor. Alright, so the three types of graph we're going to discuss is displacement versus time, velocity versus time, and acceleration versus time. It's important to remember that time is always going to be on the x-axis. Alright, first one we're going to talk about is displacement versus time graph. So if it's above the x-axis, is going to be the positive direction, below is going to be the negative direction. The slope is going to represent the velocity. A positive slope means the velocity is in the positive direction, and a negative slope means the velocity is in the negative direction. So changing slope represents acceleration. And if the absolute value of the slope is increasing, the speed is increasing. And if the absolute value of the slope is decreasing, the speed is decreasing. So, and the area under the curve is not going to represent anything in this section. It's going to represent things later on, though. Alright, in this first example here, the slope is 0, so the object just stays in the same place over time. So no velocity, it's at position, maybe 2 or 3, and it's just staying at that position the entire time. In this case, in this diagram, the slope is not 0, and the slope is constant as well, so it has a constant it has a constant non-zero, I should say, velocity, not acceleration. Right, this time the slope is constantly changing, so if you look at the slope at this point, actually we'll do red, slope at this point be like that, slope up here be like that. So the slope is constantly changing, so there is going to be acceleration. In this case it's going to be acceleration in the positive direction because the slope is continuously increasing, so the velocity is continuously increasing. Alright, so some questions here. Which objects are maintaining a constant state of motion, meaning they're not accelerating? So that means the slope should be constant. So for A, the slope is constant, it's 0. So the velocity is 0, but it's still constant. It's not moving. For B, again the slope is constant. This one is moving in the positive direction. It started in the negative direction, or started at a negative position and then moved in the positive direction. C, again, C is going to be accelerating because the slope is constantly changing and it's going faster and faster and faster because the slope is increasing over time. So that one is accelerating, so that one is not going well here. So that one is not maintaining a constant state of motion, so it is accelerating. D, again, we have a constant slope. It is a negative slope, so it's moving in the negative direction, but it is moving, it is not accelerating and maintaining its state of motion. And then E, just like A, it starts at a negative position and stays at that same negative position, so it is not accelerating as well. So the answer would be A, B, D, and E. Alright, which objects are accelerating? So we just said that A, B, D, and E are not accelerating, so that means object C must be accelerating. So it is, because it's changing its slope. Questions about the same graph here. So which objects are not moving? So we said A is not moving because the slope is 0, so that means the velocity is 0 and the position just stays the same throughout. B has a non-zero slope, so that means it does have velocity and its position is changing over time, so it is moving, so not B. C, again, its position is changing over time. It starts out not moving very fast down here, but it increases its velocity, so it is moving. D, again, has a slope. Even though it's negative, it is still moving, just in the negative direction. And E, again, maintaining its position at something negative, so it's not moving. So this one would be A and E. And the next question here, which object changes direction? So definitely not A for the change in direction because it's not moving at all. B, slope is constantly positive, so it is not changing direction. C, it continuously moves in the positive direction. The velocity is changing the whole time, but the velocity is always positive, so it is always moving in the positive direction. And then D is constant velocity in the negative direction, so it never changes direction. And E, again, constant velocity overall, so it never changes direction, so the answer to this would be none of these. And if we were to draw a position versus time graph where the object is going to change direction, it would look something like this. We'd have it start off positive, and then as the slope got smaller, it's slowing down. Then its slope is 0 right here, so it'd stop right there, and then continue in the negative direction where it's slowing down. So right here is where it changed direction. So it'd be start the fastest here. Get the highlighter. Start the fastest here, right there. Slow down. Stop right there for a moment, and then start going in the opposite direction as our slope becomes negative. So our velocity is in the negative direction. And you can look at it. Position's going up, 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 and the position starts going down, 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 down toward the negative. So that's where it changes direction right there. Alright, which object has the greatest speed? This is kind of a tricky one here. So we said A is not moving, so it's not going to be A. E is not moving, so it's not going to be D. And we're looking for the greatest speed, so it can be positive or negative velocity here. So B and D, B has a steeper slope, so a greater slope, so it's going to have a greater speed. So it's definitely not D. If we look at B and C, C probably has, like right there, has a steeper slope at the end of it than B does. So C at the end is moving faster than B because its slope is bigger at the end. Down here is definitely moving slower than B, but by the time we get to the end, that's where it's going to be the fastest. So we'd say C at the end of its motion. Alright, which object has the least non-zero speed? So, non-zero speed, so it's not A, because that's 0 speed, not E, that's 0 speed. We said B is bigger than D, so it's not B, so B has a larger speed than D because its slope is bigger. So between C and D, C is going pretty slow right there, so its slope is probably smaller than D at the beginning. So we could say which object has the least non-zero speed? C at the beginning. Alright. Next question here. Sketch a displacement versus time graph that represents an object moving at constant velocity in a negative direction. Alright, we can start this one anywhere because it doesn't tell us where to start. We just need to make sure it has a negative slope and it is not changing, and that slope is not changing. And I'll do my best to draw that here. So let's say we start in the negative direction, and it's going to continue in the negative start in the negative position. It's going to continue in the negative direction, so just be a straight line like that. So as long as your slope is negative, it doesn't matter how you draw it. This would be correct, as would that. You could also even cross the line if you wanted. That wouldn't change anything. Alright, next question. Sketch a graph of an object that is traveling in the positive direction and slowing down. So if it's traveling in the positive direction, we just start off with a positive slope, and that slope has to become less and less positive over time, or smaller and smaller over time for the slope. So we're going to start steep slope, and it slows down over time. So you can see right here is our steepest slope, so that's our greatest speed. Right here is our least steep slope, so that's our slowest speed. So it's slowing down as the slope decreases over time. Right. Last question for displacement versus time, I believe. Sketch the graph of an object that starts at position 0 with a positive velocity, slows down, stops, and then accelerates in the negative direction. So we're going to have the slope change direction from positive to negative at some point here. So this is going to start at 0, go up, slow down, and then when it gets to this flat part right here, it's stopping briefly, and then the slope changes to negative and it goes down like that. So again, we stop right there, and then this would be positive velocity, and this side would be negative velocity. I'll talk about velocity versus time graph. In this case, a horizontal line does not mean zero velocity unless it's zero on the graph, so it's a little different. It's in a displacement versus time graph, a horizontal line meant that there is no velocity. For velocity versus time graph, that's not true unless the horizontal line is at 0 on the graph. And a horizontal line just means constant velocity, and 0 is a constant velocity. The slope of the line is the acceleration, and the area under the curve now is the displacement. And area above the x-axis is positive displacement, and area below the x-axis is negative displacement. One other important thing to remember is that if you're ever asked for average velocity, which you probably will be, is equal to the total displacement over time. And you can find the total displacement using the area under the curve thing. This example here, we have a velocity versus time graph, and it is just a straight line. So we have constant velocity, and the slope is 0, so our acceleration would equal 0. And for our displacement, it'd be the area under the curve here. And to figure that out, its velocity is 10 times our time is 5, so our displacement would be 50 meters because the area under that curve is 50. Alright, so again, the slope of this graph is the acceleration. It's not 0 here. So the slope of this is going to be rise over run. So we start at 0, 0. We go from 0, 0 to 4. So it's going to be acceleration equals 4 over 1. So our acceleration would be 4 meters per second squared here. And it'd be the same value no matter which two we chose. And then our displacement is going to be the area under this curve, so under here. So if we want to do this triangle right here, it'd be 1/2 base times height. So it'd be 1/2, our base would be 5, and our height would be 20. So our displacement would be 50 meters. Alright, so some velocity versus time graph questions here. Which objects are maintaining their state of motion? So constant velocity again. So A, velocity is not changing since it's a straight line. So A is maintaining its state of motion, constant velocity. B, its velocity is changing because the slope is not 0. So it is not constant velocity. D, this part from here to here is constant velocity, but this part right here is not, so it would not be D. And E, again, velocity is not changing, slope is 0, so there's no acceleration, so that is constant velocity. So the answer to this one would be A and E. Alright, which objects are accelerating the entire time? So A, we said, is constant velocity, so not acceleration. B is, the velocity is constantly changing, and the slope is never 0, so it is B. C, slope is constantly changing, so it is C. D, it is accelerating for part of it, but not for all of it, so not D. And then E, just like A, slope is 0, acceleration is 0, velocity doesn't change. So our answers for this would be B and C. And which object changes its acceleration? No acceleration for A, B is a constant acceleration, C is a constant acceleration, D goes from some non-zero acceleration to zero acceleration, so it does change its acceleration, and E again, not changing the velocity at all, so not E. So the answer to this one is D. So now we're going to sketch some graphs here. Sketch a graph of an object that is moving at constant velocity in the negative direction. So again, it doesn't tell us what, or actually, constant velocity, so the line is going to be horizontal and it has to be in the negative direction. So it's going to be below the x-axis to make it negative, so it's just going to look like that. So it'd be constant velocity in the negative direction. So we can't have a slope on that, it should be a straight horizontal line. Alright, number 5 says sketch the graph of an object that starts with a positive velocity and has a negative acceleration. So to start with a positive velocity, we start above the x-axis, and negative acceleration means the slope is going to be negative. So it's going to go down and look something like that. And again, once we get to this point right here where it crosses the x-axis, that's where it changes direction. And goes from the positive direction up here to negative direction down here. So moving in positive direction. And down this side would be negative direction. Okay. Sketch the graph of an object that is thrown up and caught at the same height. Right, so this one, again, we're throwing it up to begin with. We'll assume that's the positive direction. So it's going to start with a positive velocity again, and acceleration due to gravity is down, so it's going to be negative. So it's going to look very similar to what we did last time. So it's going to have start with a positive velocity and have a negative acceleration, and so it's going to go, and it's going to have to cross the axis, and once it crosses the axis, it's coming back down, and then ends up on the other side there. And if it's caught at the same height, that and that should be the same, because it's going to have the same velocity at the equal and opposite velocities at the beginning and end. And again, that would be the highest point. Alright, velocity versus time graph. This one, how far does the object go during the first 6 seconds? So we need to find the area under the curve. So our area under the curve is going to be this area and this area for the first 6 seconds. So that area is going to be 1, 2, 3, 4. So it'd be a 4 by 2 cube, so from 2 to 4. So it would be 8 divided by 2. That area would be 4. And this area is going to be 4 high times 2 across. So that's going to be 8. So our total displacement, or how far the object traveled, would be 12 meters. And what is the object's average velocity during the first 6 seconds? So to find average velocity, we said V average equals total displacement, which is 12 meters, divided by 6 seconds is our time for the first 6 seconds. Average velocity in that time be 2 meters per second. Right. This one says was distance traveled. It should say what is the displacement? Is a better question. What is the displacement of the object during this graph? So I'm looking for the whole time here. Just going to want to divide this up into triangles. So we're going to have that triangle, this square, this triangle. So we've got triangle 1 is right there, box 1 is right there, triangle 2 is right there, triangle 3 is right there, triangle 4 is right there. Alright, So that first triangle is going to be 60 high, 10 across. So 60 divided by 2, that, or 600 divided by 2, I'm sorry. So 600 divided by 2 is going to be 300 for that one. This square is going to be 60 times 5. So 300 there as well. This triangle right there is going to be from 15 to 30. So 600 times 15. Then we're going to have to divide that by 2. So 600 times 15 is 900. We take that answer divided by 2, we get, oops, that's not good. The answer divided by 2, we get 450. Next we'll do this triangle right there. This one is going to be 10 times negative 40 divided by 2, and it's below the axis, so it should be a negative number. So 10 seconds times 40 is going to be 400, divided by 2 is negative 200. And this last triangle right there, it's going to be, this time we've got 15 seconds times 40 is going to be 600. It's a triangle, so we're going to divide it by 2. So that triangle right there is going to be 300, or negative 300 because it's below the axis and it's negative 40. So now we add up all these. We've got positive 600, 450, so that's 1050 positive minus 500 negative. So our total displacement of the object is 550 meters. And if we're looking for the total distance like the question originally asked, we do the 1050 from the top and we just add this because the distance doesn't care about direction. So for the total distance, that would be displacement. And for the distance, it would end up being 1550 meters. Right. Time graphs, we won't spend quite as much time on this, but a horizontal line of an acceleration versus time graph, again, does not mean zero acceleration unless it's at the 0 point. It just means constant acceleration. If the slope is not 0, that means the acceleration is changing. And when you have changing acceleration, or the slope of a changing acceleration, it's called jerk. That is the term in physics for like what changing acceleration is. So it's like the acceleration of acceleration is called jerk. We don't need to know that, it's just kind of interesting. And the area under the curve is going to be the change in velocity. We had to sketch the graph of an object with negative acceleration, acceleration versus time graph. We would just make a horizontal line below the x-axis. So it's constant acceleration because it's not changing at all, and negative so it's below the line. Alright, so last one here. What is the change in velocity for the time 0 to 4 seconds? So to find the change in velocity, we need to find the area under the curve from 0 to 4. So enter into that part. For that one, it's going to be just 2 times 2. So change in there is going to be, or the area under that curve is going to be 4. This one, it's on the line, so it's 0. So for the change in velocity for 0 to 4 seconds, we'd have 4 meters per second. And change in velocity from time 4 to 6. And under that curve, so it would be 2 times negative 2 this time. So the change in velocity for 4 to 6 seconds would be negative 4 meters per second. So if we ask for the overall change in velocity of this, it'd be 0 for the overall change in velocity. And if we wanted to find the average acceleration for this, it would be equals change in velocity over time. And so that would be, final would be negative 4 minus 4, so over time, negative 8 over 6 seconds. So it would be average velocity over this time, or average acceleration would be 4/3 or 1.3 meters per second squared.